Hello. So let's do another example. And similar to the previous example, this one is a little bit harder. And we're going to have to do a couple of different differentiation rules at once. And I didn't mention this in the previous video, but whenever you do differentiation rules and you have several in one, you want to move outward, inward. So in this example, for example, this function is principally first of all, this is a fraction, right? So we have, a function divided by another function. And then while evaluating the derivative of the fraction, so while doing the quotient rule, we're going to have to do the chain rule as well, because the numerator is a composite function. And so we can write this as, the top function, the high function, divided by the low function. And remember that the rule, so h divided by L, the quotient rule is low times t high minus high times t low, all divided by low squared. And so now let's think about what are like h and L and h prime and L prime. And we know h and L, right? So let's write this down. H is equal to, the top function is e to the 4x squared. The low function, the bottom function, is 2x. And then we can also write down L prime really easily. L prime is just 2. It's the derivative of 2x. And now let's talk about h prime. So h prime, we need that in order to plug that into our formula for the quotient rule. So we need to plug it in right here. And we need to do the chain rule. So this is a composite function. And so let's do that. So, we want to take the derivative of e to the 4x squared. And just like we've been doing previously, let's kind of identify our outside, or determine our outside and our inside. So our outside is, hopefully you can see, this is e raised to something. So our outside is going to be e to the u. Our inside is what's on the inside, so 4x squared. So this is 4x squared. Our outside prime, the derivative of e to the u, or e to any variable, is just e to that variable, so e to the u. And then the derivative of 4x squared is 8x by the power rule. And then, of course, we have our rule. So we do the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. So we're going to do the derivative of the outside evaluated at the inside. So this is going to be e to the 4x squared times, so we multiply by the derivative of the inside, times 8x. 8x. And so then h prime, the derivative of our top function, we can write down as 8x e to the 4x squared. Great. And I just put the 8x on the other side because we're multiplying and it doesn't matter which side it goes on. So now let's finish out this problem. Let's fill in. And so we just fill in low d high minus high d low over low squared. So this is 2x, that's our low. D high, we just calculated, 8x e to the 4x squared. Low d high minus high, so e to the 4x squared. D low, 2, all divided by low squared. So 2x squared. Great. And we're done. And I'll just point out, so you can simplify this a little bit. You can maybe factor out an e to the 4x squared and simplify a little bit. But, just for right now, I think it's okay to just write down just the straightforward kind of working of it.